Good morning, my dear students of first secondary. Today we are going to talk about lesson 5 in algebra, second term, finding the multiplicative inverse of the matrix. Finding the multiplicative inverse of the matrix. Let's go. Lesson 5, multiplicative inverse of a matrix. If A and B are two square matrices, if A and B are two square matrices, and each of them is of order 2 times 2, and A multiplied B equals B multiplied A equals the identity matrix, where I is the unit matrix or the identity matrix of order 2 times 2, then each of the two matrices A and B is a multiplicative inverse to other. So if we want to prove that the two matrices A and B are multiplicative inverse to each other, first you will find A times B. You will find that A times B equals to the unit matrix of order 2 times 2. Then you will find B multiplied A, the matrix B multiplied by matrix A. You will find that B multiplied A also will be equals to the unit matrix of order 2 times 2. So if A times B equals B times A, here, if A times B equals B times A equals to the unit matrix, so we can say that the matrix A is the multiplicative inverse of the matrix B, or the two matrices A and B are multiplicative inverse to each other. Okay? How to find the multiplicative inverse of a 2 times 2 matrix? If we have a matrix A whose elements are A, B, C, and D, then the multiplicative inverse of the matrix A, which is denoted by the symbol A to the power of -1. So A to the power -1 is called A inverse, or the inverse of the matrix A. Is defined when the determinant of the matrix A is not equals to 0. So first you have to find the value of the determinant A and to check that the value of the determinant A is not equals to 0. Then you will find the A inverse by using the rule. A inverse equals 1 over the value of the determinant multiplied by the adjoint matrix. This is what we call it, the adjoint matrix of A. How can we find the adjoint matrix of A? By swapping the elements of the main diagonal. Here we have A and D. We are going to replace their places. So A will go up and D will go down. And changing the sign of the other diagonal, we are going to change the sign of the other diagonal. So it will be equals to, instead of B, it will be equals negative B, and instead of C, it will be negative C. Where A multiplied A inverse equals A inverse multiplied by A, and this will be equals to the unit matrix R. Okay? Let's take an example to explain this lesson more. Okay? Let's go. Example 1, find the multiplicative inverse if it exists. Okay, so sometimes we have the multiplicative inverse, and in other times we can't find the inverse or the multiplicative inverse of each matrix. Okay, and this is depend on is this matrix is a singular matrix or it is not a singular matrix. So what is the singular matrix? The singular matrix is its determinant equal 0. Its determinant equal 0. And if the determinant of the matrix equals 0, so we can't find its multiplicative inverse, as we are going to see in this example. Okay? Example 1. Here we have a matrix A whose elements are -2, 2, 3, and -4, and we want to find if exists. We want to know if it has a multiplicative inverse or not. The first step, we have to find the value of the determinant A. So it will be -2, 2, 3, and -4. Find the value of this determinant, multiply -2 times -4, it will be equals to 8, minus the multiplying of the other diagonal, 2 times 3, it will be equals to 6. 8 minus 6, it will be equals to 2. This determinant not equals to 0. This determinant not equal to 0. So we can find A inverse. So we can find A inverse. Okay, the inverse of the matrix A. Okay, how can we find A inverse? A inverse equals 1 over the value of the determinant A multiplied by the adjoint matrix. Multiplied by the adjoint matrix. Okay, so A -1 will be equals 1 over the value of the determinant, 1 over 2, the adjoint matrix multiplied by the adjoint matrix. How can we find the adjoint matrix? Again, by swapping the two elements of the main diagonal. So we will write -4 and -2. Okay, and changing the sign of the other diagonal. So it will be -2 and 3. -2 and -3. We change the sign of 2, it will be -2. We change the sign of 3, it will be -3. Okay? Then multiply the element of the matrix, all the element of the matrix by half. Half times -4, it will be -2. Half multiplied by -2, it will be equals to -1. Half multiplied by -3, it will be equals to -3 over 2. Half multiplied by -2 will be equals to -1. So the inverse of the matrix A, okay, the inverse of the matrix A is the matrix whose elements are -2, -1, -3 over 2, and -half. Okay, and you can check this matrix. Okay, you can check your answer by multiplying A times A inverse. If you multiply the matrix A times the matrix A inverse, you must get the unit matrix 1, 0, and 0, 1. You have to get the identity matrix. Okay? Okay. In the second example here, find the multiplicative inverse if exists of the matrix B, where B is the matrix whose elements half, 2, 3, and 12. First, again, we must find the value of the determinant of B. Half, 2, 3, and 12. Half times 12, it will be equals to 6, minus 2 times 3 equals 6. So 6 minus 6 will be equals to 0. Since the determinant of B equal 0, so we can't find the multiplicative inverse of the matrix B. So B inverse, we will write B inverse is not defined, So we will write B inverse is not defined, or we can say not exist. B inverse is not exist. Okay? we can't find the multiplicative inverse of the matrix B because the value of its determinant equal 0. So this matrix is called a singular matrix. This matrix B is called a singular matrix because the value of its determinant equal 0. Okay, let's go to another example. If the matrix A equals 2, 5, 1 and 3, then find A inverse. Here in this example we want to find A inverse, which is the multiplicative inverse of the matrix A. Okay? Solution. First, we have to find the value of the determinant of the matrix. So it will be 2, 5, 1, 3. 2 times 3 equals 6. 1 times 5 equals 5. 6 minus 5 equals 1. Not equal to 0. Yep. So we can find A inverse. We can find A inverse. Okay? Okay. How can we find A inverse? The value of A inverse equals 1 over the value of the determinant of A multiplied by the adjoint matrix. Multiplied by the adjoint matrix. This is equals to 1 over the value of the determinant is equals to 1. And what is the adjoint matrix? We form the adjoint matrix by swapping the two elements of the main diagonal. So instead of 2 we will write 3. Instead of 3 we will write 2. Okay? And we will change the sign of the other diagonal. So it will be -1 and -5. Okay? 1 over 1 here is equals to 1. So the inverse of the matrix A will be 3, -1, -5 and 2. You can check your solution by multiplying A and A inverse to get the unit matrix I. Okay? Okay, let's go to another idea. Example 2. Find the real values of x which make the matrix A has a multiplicative inverse in each of the following. Okay? Here in this example we want to find the values of x which make the matrix A has a multiplicative inverse. Okay? The matrix A has a multiplicative inverse in one condition. Okay? In one condition, that the value of the determinant of A must be not equals to 0. Okay? So first solution. First, we are going to find the value of the determinant A. It will be x, 3, 12, and x. Okay? We will put the value of this determinant equal 0. Okay? So, to find the value of x, first we will find the value of x which make the matrix A has no multiplicative inverse. Then, by using this way, we will know the values of x which makes the matrix A be having a multiplicative inverse. Okay? Let's find the values of x. X times x will be x power of 2. 3 times 12 will be equals to 36. X power of 2 minus 36 equals 0. Okay? So x power of 2 equals 36. We want to find the value of x. So x will be equals positive or negative the square root of 36. So x will be equals to positive or negative 6. Okay? So 6 and the negative 6, these are the value, okay, which makes the matrix A has no multiplicative inverse. So we will write, therefore, the matrix A has no multiplicative inverse, has no multiplicative inverse. Okay, if x equals positive or negative 6. So the matrix A again, so the matrix A has a multiplicative inverse. هيكون بقى عندها multiplicative inverse امتى بقى مستر؟ if x belongs to R all the numbers except 6 and negative 6. All the number except mean 6 and negative 6. Okay? Okay. Let's solve example B. Solution here, this is solution of A, and here we are going to find solution of B. Okay? Here first we are going to find the values of x which makes the matrix B has no multiplicative inverse. And how we can find these elements? First, by putting the value of the determinant B equal 0. So you will write put the value of the determinant B equal 0. So it will be x minus 1, 4, 3, x minus 2 equals 0. Okay, x minus 1 multiplied by x minus 2, x minus 1 multiplied by x minus 2 minus the multiplying of the other diagonal will be equals to 3 times 4, which is equals to 12. And all of these equals to 0. First we are going to multiply the two brackets together. X times x will be equals to x power of 2, and negative 1 times x will be negative x, and we have x times negative 2 will be negative 2x, so their sum will be negative 3x, and we will multiply negative 1 times negative 1, it will negative 1 multiplied by negative 2, which will be equals to 2, and this is equals to minus 12, all of this equals to 0. So now we have x power of 2 minus 3x minus 10 equal 0. Okay? By using your calculator, by factorizing, you will find that x equals 5 or x equals negative 2. X equals 5 or x equals negative 2. So x equal 5, the two values 5 and the negative 2, these values which makes the matrix B has no multiplicative inverse. So we will write, therefore the matrix B has a multiplicative inverse. The matrix B has a multiplicative inverse, okay, if x belongs to R except 5 and negative 2. Okay, so x will have, the matrix B will have a multiplicative inverse. Okay, it will has a multiplicative inverse if x belongs to R except 5 and negative 2. So you can replace x by any number belongs to R except 5 and the negative 2. Any number in R except 5 and the negative 2 will make the matrix X has a multiplicative inverse. But the elements 5 and the negative 2 are the elements which will make the matrix A has no multiplicative inverse. Okay? Thank you so much. Until we meet again next time, goodbye and good luck.